You tap on the screen, a symbol lights up, and suddenly the entire internet is in your hands. That's Wi-Fi defined in the simplest of terms. But have you ever stopped to wonder how it actually works and what goes behind your doom scrolling? Let's take a deep dive into one of the most interesting technologies of the present day. What Wi-Fi actually is, and why the name messed everyone up. Let's start with the part almost everyone gets wrong: the name itself. Wi-Fi sounds technical, like it must stand for something serious and scientific. Wireless fidelity. That's what most people assume. It feels right, like hi-fi for music, but here's the plot twist. Wi-Fi doesn't stand for anything at all. Zero. Nothing. It's basically a brand name that got so popular, it hijacked an entire technology. Back in the late 1990s, wireless networking was a complete mess. Every company was doing its own thing. Devices didn't talk to each other properly, and engineers were throwing around names like IEEE 802.11, which is about as friendly as a tax form. A group of tech companies formed an alliance to fix this, and they realized something important very quickly. Nobody outside a lab was ever going to say, "I'm connecting to my IEEE 802.11 network." So they hired branding experts, who, by the way, were literal naming professionals. And those professionals came back with Wi-Fi. Short, smooth, easy to say, and vaguely familiar because it echoed hi-fi, a term people already associated with quality. The name didn't need to explain the tech. It just needed to feel trustworthy. And that decision worked so well, it erased the technical name from everyday language entirely. So when we say Wi-Fi today, we're not really naming the technology itself. We're naming a certified standard, a promise that your phone, laptop, TV, fridge, and smart doorbell can all speak the same wireless language without losing their minds. That little Wi-Fi logo on your router isn't decoration. It's a badge that says, yes, this thing plays nicely with others. At its core, Wi-Fi is simply a way for devices to talk to each other and the internet without cables, using radio waves instead of copper wires. Same basic idea as a walkie-talkie, just faster, quieter, and way more complicated. And that's where things start getting interesting. How Wi-Fi works, or how invisible waves carry your doom scrolling. Now here's the part that sounds like science fiction, until you realize it's happening around you right now. Wi-Fi works using radio waves, the same family of waves used for FM radio, Bluetooth, and even some baby monitors. These waves are invisible, long, and incredibly good at slipping through walls, floors, and furniture like they own the place. Your router is basically a tiny radio station sitting in your house. When you turn on Wi-Fi on your phone starts scanning the area, listening for routers shouting their network names into the void. Those names you see pop up? Those are SSIDs, which is just a fancy way of saying Wi-Fi name, whether it's something normal or unhinged, like FBI surveillance van. Once you connect, the router assigns your device an IP address. Think of it like a seat number at a concert. The router now knows exactly where to send information meant for you, even if 10 other devices are connected at the same time. Without that step, your YouTube video might end up on your neighbor's smart fridge. When you tap a video, your phone sends a request, but not as one big chunk. It breaks everything into tiny data packets, microscopic envelopes filled with ones and zeros. Those packets get converted into radio signals by slightly changing the shape and timing of the waves, kind of like Morse code on steroids. The router receives those packets and forwards them to your internet service provider, which passes them along to massive servers somewhere across the world. The response comes screaming back the same way, packet by packet, until your phone reassembles everything into a perfectly smooth video. All of this happens in milliseconds, which is honestly wild when you stop to think about it. And yes, sometimes it lags, because even invisible waves have traffic rules. Who invented Wi-Fi and how it accidentally took over the world? Wi-Fi doesn't have a single inventor sitting dramatically in a garage somewhere and having a sudden lightning strike of invention. It's more like a long, slightly chaotic relay race where scientists kept passing the baton forward, sometimes without even realizing how big the finish line would eventually be. One of the most important legs of that race happened in Australia in the early 1990s. A research team at CSIRO was trying to solve a deeply unsexy but absolutely critical problem: how to stop wireless signals from turning into garbage the moment they hit walls, furniture, or humans existing indoors. Early wireless signals bounced around rooms like confused ping-pong balls, interfering with themselves and collapsing into noise. If you couldn't make wireless stable inside buildings, it would never be practical. The CSIRO team cracked that problem using techniques originally developed to detect exploding stars and black holes. Yes, Wi-Fi owes part of its existence to radio astronomy. That breakthrough made it possible for signals to reflect intelligently, arrive intact, and actually carry usable data indoors. Once that door opened, the rest of the industry rushed through it. By 1999, the first consumer-ready Wi-Fi standard, 802.11b, hit the scene. It topped out at 11 megabits per second, which today sounds like something you'd accidentally get on hotel Wi-Fi while standing in the hallway. But at the time, it felt like magic. No cables, no dialing noises, just laptops talking to the internet through thin air. From there, Wi-Fi didn't explode loudly, but crept in gradually. Each generation brought faster speeds, better range, and smarter ways to juggle multiple devices without collapsing. Meanwhile, the branding stayed almost suspiciously simple. No one needed to understand modulation schemes or frequency bands. You just connected and moved on with your life. And that makes its advancement through decades even more interesting. How Wi-Fi evolved in reverse. Once Wi-Fi proved it could actually work without collapsing the moment someone closed a door, the real race began. Speed, stability, and figuring out how to handle more than one device without having a meltdown. The early versions were charming in a very dial-up era way. Wi-Fi 1 and 2 were fine for checking email and loading web pages line by line, but they were never designed for a future where everyone in a house would be streaming, gaming, video calling, and updating software at the same time. As laptops became common and smartphones entered the picture, Wi-Fi had to level up fast. Each new generation quietly improved how data was shared, how interference was handled, and how efficiently multiple devices could talk at once. Wi-Fi 4 introduced better speed and range. Wi-Fi 5 pushed performance high enough for HD streaming to feel normal. Wi-Fi 6 changed the rules entirely by focusing less on raw speed and more on traffic management, allowing routers to juggle dozens of devices without choking. That's why modern Wi-Fi feels different. Your router isn't just blasting data everywhere anymore. It's scheduling, prioritizing, and slicing up airtime like a very patient air traffic controller. The reason your video call stays clear while someone else downloads a game update isn't luck. It's math, timing, and smarter protocols working quietly in the background. And the naming system finally caught up with reality. Instead of expecting normal humans to understand 802.11ax, the Wi-Fi Alliance renamed generations Wi-Fi 4, 5, 6, and now 7. Same tech, clearer labels, fewer headaches. It's a small change, but it's part of why Wi-Fi feels approachable instead of intimidating. What actually uses Wi-Fi? It's way more than you think. When most people think of Wi-Fi, they picture phones and laptops. That's understandable, but it's also wildly incomplete. Wi-Fi has quietly crept into almost everything that plugs in, lights up, or claims to be smart. TVS stream entire libraries without cables. Consoles download games bigger than movies. Smart speakers sit in corners waiting patiently for someone to say their name. Then there's the background stuff you forget exists until it breaks. Thermostats adjusting temperature automatically. Security cameras streaming live footage. Doorbells sending alerts. Robot vacuums mapping your floor plan like tiny explorers. All of that relies on Wi-Fi maintaining a steady, low latency connection, often 24/7. Even outside the home, Wi-Fi has become infrastructure. Offices rely on it for cloud work. Hospitals use it for equipment and monitoring. Airports treat it like electricity, something people expect without thinking. Public Wi-Fi networks handle massive volumes of traffic every day, juggling thousands of devices while trying to remain secure enough to function. What makes Wi-Fi so powerful isn't just speed, it's flexibility. It adapts to tiny sensors, massive screens, and everything in between. It scales from a smartwatch to a stadium. And unlike cellular networks, it's something individuals can own, control, and customize, which is why it became the backbone of the modern digital environment. At this point, Wi-Fi isn't a convenience, it's an assumption. The future of Wi-Fi, and why it's about much more than speed. When people talk about the future of Wi-Fi, they usually default to the laziest prediction possible. It'll be faster. And yeah, that's true, in the same way saying cars will go quicker technically explains nothing about highways, traffic lights, or self-driving systems. Speed is the headline, but it's not the story. The real future of Wi-Fi is about how networks think, not how fast they sprint. Take Wi-Fi 6E and Wi-Fi 7. The big upgrade isn't just higher throughput, it's access to the 6 GHz band, which is basically a brand new multi-lane highway that isn't clogged with microwaves, baby monitors, and your neighbor's decade-old router. That extra spectrum means less interference, cleaner signals, and dramatically lower latency. In plain terms, your connection stops feeling like a crowded elevator and starts feeling like an empty escalator. Wi-Fi 7 pushes this even further with something called multi-link operation. Instead of your device choosing one band and hoping for the best, it can use multiple bands at the same time, dynamically switching or combining them based on congestion and signal quality. That's huge for things like cloud gaming, AR glasses, and real-time collaboration tools, where milliseconds actually matter. But here's where it gets interesting. Wi-Fi is quietly learning context. Modern routers already prioritize traffic without you noticing. Video calls get protected. Streaming gets buffered intelligently. Game packets sneak through faster than background updates. In the near future, routers will lean even harder into AI-driven traffic management, predicting usage patterns and allocating bandwidth before you feel the slowdown. Your network won't just react, it'll anticipate. Wi-Fi is also expanding beyond internet access into sensing. Researchers and manufacturers are already using Wi-Fi signals to detect motion, presence, and even breathing patterns by analyzing how radio waves bounce around a room. That means future Wi-Fi networks could help with home security, elder care, and smart environments without cameras or wearables. Your router might know someone's home simply by how the signal shifts. And no, Wi-Fi isn't getting replaced by 5G or whatever comes next. They're actually becoming teammates. Cellular handles mobility and wide area coverage. Wi-Fi dominates indoor spaces, high-density environments, and local device ecosystems. Your phone already switches between them automatically, and future devices will blur that boundary so completely you won't even think about which one you're using. So the next time you see that Wi-Fi icon quietly glowing in the corner of your screen, remember this. It's not just giving you internet. It's coordinating radio waves, managing digital traffic, and quietly evolving to keep up with a world that refuses to slow down.